the changes in the certification itself. So because in the prior certification, there was not so much emphasis on some of the areas in the network. So today we are going to talk about networking and protocols and things like that, but it's going to come back to threats and how we can protect a network. So let me share screen and turn on my projection. Hello. Oh, it helps if I actually plug things in here. Sorry. Okay, so as you look at Unit 3, we're going to touch on Chapter 3, which emphasizes network devices, and threats. Right? We're going to use a little bit of Wireshark today. I wanted to expand a little bit more next week on some hands-on exercise. Possibly we'll take a look at how to be able to manage network or even working more with Linux. So I'll modify some stuff and I'll put that up. So as you downloaded the notes, which are located on your module 3, okay, we are going to take a look at some of the information that's provided in the notes, and then we're going to answer the questions. So make sure we download the notes and the assignment. We're going to go through that together. There is an extra credit game. You can play it on your own time, right? And you can earn a gift card, an e-gift card from me if you scored the highest in the class. It helps you prepare for the next quiz. Okay, so take a look at that. So let's talk about Chapter 3 with network technologies and some of the attacks. Now, this chapter doesn't cover all of the attacks. We're going to have one chapter that's going to emphasize more on the threats and the vulnerabilities. So it starts out with giving you the information on sniffing attack, right? So in sniffing attack, you're going to have the attacker analyzing what's the traffic, which is the communication of all your devices on the network, right? They can simply run a tool, a protocol analyzer, and today we are going to use Wireshark. Some of you are familiar with that. There are other protocol analyzer that's available, right? Wireshark is very common. So the sniffing attack, they use the protocol analyzer to capture your traffic. It's kind of like putting the camera on the freeway and looking at every single car that passes by. That's my analogy. So by that, they can look at the data that's being sent across the network and looking at the captured information. So they can turn it on for a while, take the capture, and looking at the report from that capture, or even the packets from that capture. And when I teach Python, right, I just talked to my class about how Python can be implemented to write a packet modifier. So they can modify the packet. So how does that happen, right? They capture it and your data is sent in a way that they could see it, and so they can modify it. So I can modify it to send the data to me instead of the actual destination by changing the destination address, right? I can modify some of the content unless the data is encrypted. So some data is not encrypted being sent because encryption tech resources, we don't encrypt everything, right? In communication, we do some encryption with some things. So for your sniffing attack, basically they look at the traffic on the network, what data is being sent using a protocol analyzer. And if it's clear text, they're able to see it. Okay, so for number 1, we can say that the attacker would utilize the scanner to determine the network traffic, the protocols, and the ports. So when we say the network traffic, it's going to show who is sending and who is receiving, right? The network traffic can include all the routers, all the switches, all the network appliances, all your mobile devices, depending on, you know, how you design your network to have these connections. The protocols are used for services. So protocols are just a set of established rules for a specific type of service. So when you're using your browser and you type in your URL, it uses HTTP, right? Hypertext Transfer Protocol. It's a form of protocol so your browser can understand, right, what the hypertext. Now, ports are just numbers that are allocated or assigned to a specific protocol and service. So when you're using your browser to connect to a website, HTTP website, right, non-secure, you're using port 80. So that number 80 is dedicated to HTTP. So in this field, we need to know the type of protocols, and we need to know the type of ports.
If HTTP is less secure than HTTPS?
Yes, and HTTPS simply is an HTTP with the secure socket layer. So it coupled with other protocol to encrypt the web traffic as it's sent. So when you're authenticating to your bank account or HTTPS website to pay your bills or, you know, log into your financial aid, etc., you're using HTTP with TLS, which encrypts that traffic for that session. So it is more secure than the regular HTTP where things can be visible, right? So how they can protect your financial information is they would implement HTTP secure or with SSL and TLS. Okay, so those websites that you see. So now the port for HTTPS is different than HTTP, right? The computer only understands numbers, okay? So when we say port value 80, it automatically knows that that connection is going to be established for HTTP compared to 443, which is that value 443 is established connection for HTTPS, right? And we'll talk about the common port. So in the networking area, we have to understand how all of these things are logically communicated. And with that, we can provide protection or security for these devices and all of the communication channels and the traffic. Okay, so I'm gonna come back to the notes because I want to share this with you. So some of the tools that we use in security, Wireshark, we're gonna look at that today. That is a packet sniffer or a protocol analyzer. It allows you to view the traffic that's in the network or on that network, be able to evaluate individual packets. So when a system communicates with another system, it sends that packet information. So when you are visiting a website, you send a packet for request. And then the server sends something back and say, oh, here it is. Here's the website you're asking for, right? So with that, what we can do is we can analyze that. And so from an administrator standpoint, you have to regularly look at it, right? You have to monitor your system using protocol analyzer. From an attacker standpoint, they can evaluate your traffic just like putting a camera on the freeway and looking at every car and then looking for that specific car with all the doors open and then go through that, right? So when it's clear text, they're gonna say, oh, that's the information I need, right? So they can use the protocol analyzer to do that. So I want to show you a website that you can use, okay? There's a website called sectools.org. They list all of the common tools. and some information. So Wireshark is always ranking high. There are other tools that you can see here, okay? Metasploit has been around for a long time, and some of you know what Metasploit is. It is a group of tools that you can use to test things, okay? And this is equipped in Kali Linux now. But back in the day, it was separated. It was not included. And so now you see some of the Linux releases would have these type of tools. So as you visit this website, you're gonna go down the list, and full disclosure, right? I'm showing you the tools, right? You can use it for learning purposes, okay? But then if you use it for other things, just keep in mind that when you're circumventing a network or a system, that's against the rule, and you can go to prison for a long time for that, okay? Anytime that you're testing any one system, make sure you have a written agreement signed, okay? Approval saying that you're allowed to do that. It is not okay to scan your neighbors, okay? Because eventually we will start scanning things and looking at things. And in this area, you are privy to a lot of different cool stuff, but it's really up to you, right? Between the black and white and the gray area, to really determine what is ethical, and we always want to be ethical, okay? So Nessus is a way that we can assess vulnerability. There's a free version, but they are proprietary, so the version that most companies use is kind of expensive. It's like about $1,000 something per license per system. So remember the first week I said, how can you look at a wireless network? How can you attack a wireless network? You would use Aircrack, right? Aircrack has great tools now with Bluetooth and everything else. So the weakest area of your home network is your smart TV, because smart TV doesn't have a lot of the security feature, even though when they update firmware, right? And then sometimes the IoT devices like Google Nest and things like that, if you don't patch it, you have issues, cameras, etc. So looking at this tool, and Snort is very much like Wireshark. It is an analyzer. The creator for Snort, they have their own consulting company now. They make different products. Cain Enable is used for cracking passwords, along with some wireless analyzer. They have some tools added. Backtrack is old, okay? Backtrack was used back in the day, and now Kali Linux have a lot of these tools built in already. So you don't need to go and grab them if you have the right version of the Linux to use.
Professor,
yes.
So through these tools, are you able to send out cyber attacks, or how does that?
You cyber attack requires a lot of different things. Cyber attack requires, if you want to cover your track, you have to mask. Also, depending on what type of attack you are pursuing, if you're doing cross-site scripting attack, you have to know how to do man-in-the-middle attack, because cyber attack really is a lot of the time they do man-in-the-middle. That means that they listen, they watch the activity, right? They're gonna try to enter a session between your client and your server, between the systems, right? And then eventually divert that traffic to you. So ultimately it is that. So there are many forms of cyber attack, okay? Now, if you want to do brute force, then you would create a bunch of zombie, getting people to click on your link and so on, and then take over those systems and then use those systems to just launch requests nonstop. And that's the simplest form, okay? So these tools are really designed for us to really evaluate our existing network and system to better protect our system on an ethical standpoint, right? The attacker standpoint, these tools are, you can buy tools, you can download free tools, there are tons of stuff. And being a script kiddie, you should test with your virtual machines, not other people's system, because when they report it, it becomes a crime, and you don't want to get involved with computer crime, especially in this field. Then you can't touch a computer again. You can't work in this field.
Not even a For personal use?
So if it's your stuff, right? Like I said, you can make your own virtual machine and do it. Okay. But when it's your neighbors or even people that live in the same household, like your roommate, and you start trying to attack them and they're not aware of it and they can report it, it's a crime. Okay. All right. So you can take a look at these. They give you the description, you know, when you get into like HPing is in Cali. There are a lot of different ones in there. So I give you a list, right? That list came from sectool.org. Okay, so let's talk about denial of service. Some of you already know what denial of service is, some of you don't, right? So earlier, the question was, how can I launch a cyber attack? Well, you can take down a web server by doing denial of service or distributed denial of service. The true difference between DOS and DDoS is that DDoS use multiple systems. Usually they use hundreds and thousands of systems to be able to launch against that one target. So if I want to take down a web server, I just continuously requesting it. So the HTTP server, its job is to respond to all the requests, right? Every time that you visit the website, you're submitting a request. You're doing a GET, okay? So the server job is to say, hey, here's the content, okay? So if you launch thousands of requests at once, it's going to be so occupied, it won't know what to do, and eventually it slows down and then it crashes, right? So that's distributed. The denial of service attack, it's a one system against another system, right? I can write a script and I can launch 5,000 requests sequentially, or I can utilize multiple core in order to do that to that system. Now, attacks require research, time, resources, right? Time and money is usually the area. Okay. So as we touch on these, we want to identify two types of applications that are for network sniffing. You can use Snort, you can use Wireshark, you can use Icmp. There are quite a few, but Wireshark has great information and tutorial, and so you can tap into it. And the more you understand how to use the tool, when one tool doesn't work, you're able to use other tools or make your own tools, right? Okay, and then after that, we're going to talk about the protocol. So in denial of service attack, the protocol that's used is a user datagram protocol, UDP. So in the internet, in the World Wide Web, in our public domain, that's what we call it, right? Usually you would see TCP IP being used. IP is used for addressing to get from one system to the next. Or TCP, make sure that your data gets to the right system. And TCP has to be connection oriented. So TCP stands for Transmission Control Protocol. Now you can also use UDP. UDP is connection-less oriented. It could care less that the connection is established. Okay. When do we use UDP? When you're streaming video, when you're listening to your internet radio on the way here, when you use things that doesn't require direct connection, when you're making a phone call to your friend on your mobile phone. Most of the voice and the video traffic is using UDP. Okay. Now, why do they use that for DOS? Because with TCP, it is like this. So in order to connect, let's say I want to connect to Eduardo, and I would say, hey, I'm connecting to you, and he has to respond to me and say, okay, I'm ready. Okay. Then I'm going to say, oh, here's my request. And then he's going to respond and say, I accept your request. So TCP requires multiple confirmation that way. And that will take time, right? So in DOS, they don't need to make sure that that connection is guaranteed. They just launch, okay? So that way, you know, give or take, you are gonna lose some, but you are gonna get through some, right? So it saves time and resources. That's why UDP is often used, and it is not secure or fully established. Okay. Now the true difference between TCP and UDP, the delivery is TCP. Okay, I mentioned that. So my analogy for this is like when you're sending a package to someone, right? You can just drop it off and it sends, and whether it gets there 5 weeks from now or 2 days from now, it doesn't matter. That's UDP. Okay? But if you're sending a package and you're tracking the package and you're making sure that somebody signed for that package, that's TCP. Okay, it confirms that that connection has to be established in order to communicate. Okay, and we use it more often now because the way that we use the internet is a little bit different than years ago. Okay, but protocols were designed from the 70s and the 80s, and we're still using it today, right? So there are some flaws in protocol. There's some good things about some protocol, and we improve some protocol. But TCP makes sure that your delivery is there. Okay, that's the true difference. And in this field, you have to know your acronyms. Okay, so my suggestion is, you know, if you're a flashcard person, you do that, but make sure that you know your acronyms. Okay, because people are going to start referring to things like DNS, DHCP. You have to know what they are. Okay. All right. So as we're writing those down, you see that, but I wanted to touch on some of the things from the lecture. So here I give you some information about protocols. So this class is going to give you the very foundation for some of the networking terms and what they are and how they're used. If you want to take networking classes specifically and know how to do it, CIS-28, that's at Moreno Valley, and at RCC it's 26A, B, and C. That's a Cisco series. But when they teach it to Cisco, you have to do them in a series. Okay. But I teach it to Network Plus for CIS-48. It's going to be available next semester. Okay. So TCP, when you look at Wireshark today, you're going to see SYN for synchronization, ACK for acknowledgement. It's kind of like when the server sees or the other system acknowledge that, oh, it's ready to receive and send. That's how you're going to see it. Okay. All right. UDP, we talked about that. IP is mostly used for address. It's connectionless. We use IP to assign the system a number, which is an address, just like your home address, right? Could be version 6, which is in hexadecimal, or version 4, which is in decimal, and it would use the dots. Okay. All right. Icmp is used to test to test connectivity, right? So when you ping someone, and you can try this, right? Let's say I open up my command prompt. You can do CMD, and you could say ping 127.0.0.1. And this is a loopback address. That means I'm pinging myself, right? My system, it's pinging itself. So when you issue this, it's gonna send in Windows system, it's gonna send 4 packets. You see it, each one, right? So when you ping, when you want to see if that system is connected and alive, okay? We do it for troubleshooting, okay? So when you go home and you're like, oh, I don't have internet, and you know, I see my router, but I cannot connect somehow, and everybody else can't connect to that router. Most likely your router is flooded, right? You've got to restart it. So you can ping it real quick. Most router at home uses 192.168.0.1. An exception for some netgear. Okay, they use a .10.1. So if you ping that IP address, if it's alive, it's going to reply 4 times. Okay. So when you're using ping, that's an Icmp. Okay. And in Wireshark, you're going to see it. It's going to echo and reply. Now in Linux, when you ping, it continuously go forever unless you count it. You can say ping dash C, which is a count 15. That means I pinged 15 times. Okay. So here it tells you how many packets is sent and how many packets is lost. Standard Windows, 4 times, right? I have 0 loss, so I'm able to ping myself. Can I ping another system? Sure. If the one next to you is on and alive, you can just ping that number, right? That IP address. So this is a version 4 we're using, okay? So this is called a loopback address. Whenever you see that, system always call home. It calls itself. It sees itself, okay? All right. So, and then another protocol that we often use in our security world is ARP. Address Resolution Protocol, okay? This simply resolves your IP address to a MAC address. There are two different types of address for that system, right? The IP is not permanent. It's for the network. So this system has a different IP than this system. They have to be different. It's distinguished. That's the number that it's going to get the traffic to the right system. Now the MAC address is for that switch, okay? The IP is for the router, okay? So at home, when you're looking at your IP address, it's going to say 192.168.0.x, 7, 10, 11, 100, right? In the here, when you look at your IP address, you can do this. You can say IP config for Windows. And it might be a lot. So you're gonna have to look at the right adapter. Remember when we work on your VirtualBox and things like that, right? You would see there's a VirtualBox wireless. So for me, I'm on a laptop, so it shows my wireless LAN. Okay. Here's my IP right now when I'm connecting to MVC network. This right here is called a subnet mask. Think of this as like your zip code to your home address. It uses that to identify the network that system exists in. Okay. So when you're looking at your home address on the internet, right, you put it in. So how do they zone in on the map? Using your zip code. So it knows like what city and the area that you're in, and then it's going to narrow down to your street. So what it does is in a network, you have a router that's going to bring that traffic, that communication to the street, okay? But which house is it going to be is where the switch steps in. So the switch is going to use, right, your address, your MAC address, your physical media access address to narrow down which system is asking. Okay. So the router only brings your traffic to that network. The switch is going to take that and narrow it down to the system, and that's the job of the switch. Okay. So that is going to give you. Now, this is a router address. Okay. Most network uses default gateway. So think of a gateway is to enter and leave. We would use a router to enter a network and leaving the network. So whenever you visit a website, it has to go through your home router. You know that. Come back through your home router. That's your default gateway. And most administrator, right, as I was trained, we always use a .1 because that's the first device that you see in the network. And then all the subsequent devices, we use logical number, right? So if I have one router and then 5 switches, I'm going to go .1 for the router, .2, you see at the end, .2 for the next switch, .3, .4, .5, and so on. But there is a max because it is a decimal number, so you get to like 254. Okay? You cannot use 255 because when 255 is used, all the bits are on, it broadcasts. Okay. So we don't use 255 because, you know, if you convert that to binary, 255, all the bits are on the broadcast. Broadcast means it sends to everybody, it doesn't receive. Okay. And again, 40A I will teach you how to subnet. Okay, question. All right. So then you can also do something like this. Let me get my screen up. If you do an ARP-A, okay, you see a switch table. So any connection that I have established, my system keeps track of it. Why is that? It buffers it so that way if it's the same connection again, it doesn't have to reestablish the connection. It just goes to that table and it says, oh, I did it already. I have a record of it. I'm just going to use that. Okay. So here is where your physical or your MAC address exists. See? ARP takes your IP and associate that with the MAC address, the media access control address, your physical address. Okay. So it's kind of like this. Okay. You have a social security number. You have your name, right? How does the government know who you are? They associate the social security number to your name. So this table associates the physical system to an assigned value in that network. Okay, that's how it's able to identify where that system is from a switch level. Okay, so on the switch, when you look at ARP, you're going to see all the systems that were connected to it. As I am looking at my system that has been connected to other things like their network, home network, and so on. So ARP-A uses everything.
Even if you're using like an IP or a VPN, will all this still show?
Yeah. So the IP that you see there, right? When you do IP config, it's for your internal network only. Kind of like your nickname that everybody calls you at home, right? But when it leaves your router, it uses a public IP, and that's using NAT, network address translation. So when you're using your smartphone has a public IP through your service provider, T-Mobile, Verizon, AT&T, right? They acquire a group of public IP and they associate that with your phone number, your UID, which is your MAC address on your phone, okay? So when you're connecting to the tower, it knows that you're part of that network, okay? Now, when you're roaming, you're entering somebody else's network. How do they know it's roam? Because you're not part of that group. Okay. It's, communication is really simple once you understand it. So in that sense, right, some IP, private IP inside the network only, public IP leaving the network. So the router sees public IP, okay? The switch and the internal appliances sees private IP. Okay, you want to know what your public IP is? Use a whois service. It's all over the web. If you search for a whois website, right, it would show your public IP address on there for your home network. And we usually only have one for our home network, unless you buy another one for your business.
So like it's off topic, but like those videos on YouTube of like the stories of when people go like on the dark web, the deep web, and they don't take the precautions going into them. So I've heard videos where they say that they go into a website and then the host of that website, they hack them. They hack like their camera and then their microphone and all that.
Oh yeah, you can turn on devices. So, but okay, so visiting, those are called water holes. There are thousands and millions of water holes, right? So, you know, they're also talk about the Chinese government, not they have water holes. So those are websites and they would lure people in, and once people go in, there's something could be downloaded. Usually it would ask you to do something, but now they can have it automated. So as soon as you visit the site, it downloaded a file, and that file activate your input and output, right? Turning on a camera and turning on microphone is a really easy script to do. Yes.
How are you able to download a file when you do JavaScript?
It's,
runs in
yeah,
the back.
just scripts in the back.
Wow.
And you can't see it. So the developer, as a developer, you don't need to show people everything, right? So if you embed it and if you don't show it, it can just download in the back. And then, so as it does that, instruct in their libraries to activate IO, all of your devices just listen for instructions. So you tell it an instruction, right? Like turn on this, just like how you enable permissions on your smartphone for certain apps, right? So the app asks you, but they can make apps that don't ask you. People can get in trouble for that, of course. Companies been sued, like Google and Facebook and so on, been sued for privacy, because that's a violation of privacy. That's a big deal here in North America, right? But other places in the world, they don't care. If you don't know who they are, right? Why is it gonna matter? So the Chinese government, they look at all the traffic for all those people. That's what sometimes people use VPN when they're there. But because they wanted to also see what you're doing, right? But here we don't. Well, Big Brother is always watching. However, right, it's not apparent that I was looking at something yesterday and I realized that my URL says Russia and I was like, oh, I better get off before it gets to me. But sometimes you go down that rabbit hole. But anyway.
It's like searching for bomb and you say bomb and then before you know it, it's like
Yeah.
Hold on. It's just when you download a program and it says like do you give this program permission to give access to your computer?
That's a certificate that they use for permission control. So, but we waive our rights all the time to allow things. Your browser listens all the time, right? So it's, that's how they build the analytics on what you search, what you like, and they advertise to you, right? That can be sold for ads and things.
Oh, you're the one that told me about the eye coordination too, right?
Yeah. So yeah, looking at things sometimes like the camera can turn on and people gets excited, their eyes get dilated. So they use AI for a lot of things. And also when you playing like virtual reality stuff, Facebook analyze all of your emotion. You know that. So when people are excited, like their eyes fluctuate a certain way, their pupils dilated, and so on. So how do they market for certain things? They look at the behavior.
You just go on YouTube and click on every single one, and go on Google and go on every single thing. So you tell us. So
Yeah.
it is a system.
I mean, you can train it that way, right? By changing your behavior. Okay.
But all that data is always going to stay like to your number, right? To that phone number that's connected.
Yeah, or that system ultimately is the computer.
So let's say you just change your number. That data is always going to stay to that number, right?
Mm-hmm. When you change your system too, when you buy a new phone, right? Unless you log into your old account again, it won't know who you are until you do that. You authenticate. Okay, so NDP gives you neighbor discovery. Okay, this is important for us, okay? I know that it's not on the question. So the routers, they look around all the time, like they say, oh, I'm here, pass stuff to me. But we also wanted to see what other systems are available. So sometimes you would use this to look at what other devices are and what kind of IP addresses that it's using. Most of the time you see that being used on the router or appliances that passing traffic, okay? Your home router does that, right? It advertises SSID. It says, connect to me, I'm here, right? As long as you authenticate. But the regular, like the automated system, it just advertises itself so that way it can quickly pass your traffic. Real-time transport. I'm on Zoom now, right? So it does use this. Okay, often you would see real-time transport protocol using on phone system, conference call, things like that. So voice over IP.
Wait, hold on. How did Zoom get hacked? During the pandemic.
Like for the, are you talking about the bonds and bonds?
I think like they were hosting like a Zoom meeting and people were able to like just go
Yeah,
in the meeting.
yeah, Zoom bomb.
How does that happen?
Well, sometimes they can try random things, but also Zoom meetings sometimes are public.
Yeah,
Like my
they
Zoom
don't have a
profiles.
password, and you just get the link and you can get in. But other times they found an exploit where you could extract the password from the URL through a little bit of injection. Yeah, and that was funny. They patched it though.
I think most of you don't know what push talk devices are, right?
Walkie-talkies?
They are kind of like walkie-talkie, but they were phones, and Nextel used to own them before they were acquired by Sprint. Now Sprint is acquired by other company, but so basically, when you can leave a message for someone, right? You just so it takes a recording of your voice, and then when you push it and send it, it sends that kind of like how you do text message with voice now, right? But it's in an analog format, and so when we digitized the mobile network, we kind of did away with all of that, and it's using like different formats. So you would see a lot of this with streaming media and devices, and then your STRP. The difference between RTP, the RTP and the RTP is that it's encrypted. Okay, so it's using encryption. So if you want secure, you would use that's RTP. So I touch on that for number 7. So the protocol that requires encryption, authenticate, and provide data integrity compared to RTP is your secure RTP, your SRTP.
Oh, I heard that ByteDance acquired a VR company. I forgot what it was called, but it's in China.
Oh, a lot of technology comes out of China. They got, they're pretty advanced. Yeah, when you go there, you don't really, people don't use money, like paper money.
Yeah.
Everything is digitized. Everything is on your smartphone. We started to transition to that now, but we're still using cash, right? Coins. Okay. So earlier I touched on NDP, right? Network discovery. So this is gonna give you the auto configuration for the IP version 6 addresses to discover other devices that have version 6 on the such as address for the router. And we mentioned that the number that you see for port number is just a value that you would. So there are so many common ports. So you have to start remembering these ports. So FTP uses port 20 and 21. So FTP is used for file transfer, and FTP stands for File Transfer Protocol. So they can have an FTP server and a bunch of files on there. Sometimes you have to authenticate it to it. So Mozilla is one of them, right? You can go to the Mozilla FTP server. Sometimes you can access it as anonymous user. You can download it, or sometimes you have to authenticate to it. Depends. So it uses port 20 and 21. You have to remember the port numbers. Okay. Just like I said, HTTP uses 80, right? SSH uses 22. And as you use it more often, you'll remember. Okay. I know it's hard at the beginning.
Lester, I remember this stick with me. When MySpace came out, I remember my cousin was using it at my house, and I remember he put his password in, and then it went to the homepage, right? And then he left. But what I remember was I was able to go back. And
yeah, so that session didn't end. That session stay alive forever.
But
So
and then it was like a couple weeks later, I tried to do it again, and then it wasn't able to.
yeah, so it times out, right? And they can build it to where the time to live is the time for the session is shorter or longer, right? And it's on the development end. When you click a back button, right, sometimes it ends that session already. You can't go back, and then you have to authenticate again to reestablish that session. Okay, but in that case, that doesn't end for a long time, maybe a few days, right? So they designed it to be that way. So earlier, there was question about HTTPS. So HTTPS is an HTTP with, right, these two. Secure socket layer is SSL, okay? And this is used to protect your traffic. It encrypts your traffic on the web, okay? Now, they has transitioned a lot over to TLS, but TLS is just an extension of this. It's replaced that because SSL has flaws. It still does. They fix some of the problem. Now, when you connect directly to certain system, right? Often you would use SSH, like when we terminal into cloud server, when we connect to a switch or a router, we would use SSH. When you're using your Raspberry Pi, you can also authenticate using SSH. So that encrypts your traffic. It's one of the better ones. Okay. We don't use Telnet. This replaced Telnet. Telnet, everything is in clear text. Clear text is a boo-boo for security. Okay. Do not use clear text stuff because people can see it and they can modify it. Okay. All right. IPsec is used for virtual private network. That's how you can remotely connect to different networks. IPsec is more secure than other technology. So it creates a tunnel. It encapsulates that traffic. So it's harder to break, but you have to set it up. Okay. So the header, that's what it will look like. So I just want to give you a little bit of image on, you know, what goes where. So you're always going to have the source and the destination IP. Think of it like sending, you guys probably don't know, but you do receive stuff in paper mail, okay? I know, I'm ancient, but yeah, paper mail where you have from and send to address, or in an email, it's like that, right? So the header, think of it that way. It would have who is it going to, where is it coming from, sometimes the size, right? The byte size, the date, and then the data is raw and it's not sequential. So when packets are sent, like the data is all scrambled, okay? So when you're sending, let's say that I'm playing a game and I'm submitting that, right? What it does is it's actually sending into multiple packets. And when it gets there, it uses sequence number to reorganize everything. Okay. So different protocols have different requirements. And so here you can see that the data comes across. So the data body is always going to be raw. Okay. That means that it's just like not in any kind of, you know, sequential manner. So when it gets to the destination, it's going to use the header and stuff to identify who that's receiving. And then the data will then be put back in the order. It's like sending a bicycle in different parts in different boxes, right? You can receive the wheel first, and then the handlebar later, and then the pedal down the line. And then when it gets there, so it's gonna reassemble everything back, and that's how your system works. Okay. Let's move further. Okay. So that's a different type of header. And remember that when you're looking at port number, be careful because sometimes, most of the time TCP and UDP port is the same. Some protocol uses TCP only. Some uses both. Some uses only UDP. So when you look at that online, you say, okay, what is this port number? It's going to tell you TCP like 22, right? Or UDP 21. Okay. So for mail, we would use SMTP for simple mail transfer protocol. This is often used like whenever you access your student email, you're using SMTP. There's a mail server that's in charge of that. And it uses also for web purposes like for Outlook. Okay, so some of the ports. You can use uncommon ports. You can go all the way up to 7,000. But the common ports is what's known in the industry. POP3, this is used like when you use your Gmail. Okay. So in forensic, we explore a lot of this area and looking at mail filters to see, because people can actually craft your email, you know that, and impersonate you. You've seen those fake emails that come through. And then you look at the email address, it's totally fake.
I get a lot of those emails from the school email that they're hiring and all that. I remember a while ago they sent out an email to watch out for those types of job offers. How do people get in like do that? And I remember years ago
someone clicked something inside that mail network. Yeah. And then they take over the account. Usually it's they fish them out. Okay. So
sorry. Talking about phishing. Like just like living like in today's time, like just how dangerous it is just to like talk to someone in public in general. Like I meet him in public, right? And then we just start talking, and then I'm like, okay, what's your name? And he told me his name, right? Okay, how old are you? He told me his, and then where you information, right? It's just I can use that to like phishing, right? Like
You can, yeah, you can use any, I don't need to meet anyone to fish someone. I can find that person by Googling them and, you know,
Everything's public now.
looking up information.
Yeah.
Mostly everything is
So how
public.
can
Your
one
health
protect themselves
information
from
is.
like phishing, like when you're creating those security questions or the answers and all that? Just like come up with like a fake.
Yeah, phishing doesn't have to be that. Phishing can just lure someone to give you more information, like their account number, their social security number. You won, you know, a trip to Hawaii, give me some of your, you know, information, your social security number, so your account number, so I can transfer, you know. And, you know, or now you hear all the IRS, you're getting penalized by the IRS, you know, so there are ways to really psychologically get someone to give
Like
you.
in some warehouses, I've noticed there's flyers or like banners that says "Be careful who you talk to," like, and then it's just like. phishing
Yeah.
and all that.
Also, when you start, if you do get a job with security clearance, you cannot talk about your job ever. Okay. Right? You can even sometime who you're employed by. Okay. So sometimes that will be the case. So you got to make sure that you look at those agreements. If they ask you not, and also not taking pictures, sometimes not even going to the bathroom by yourself. So, you know, yeah.
Wait, why are so?
Well, someone has to go in there because they're afraid that you would take things out. You know, you've seen movie with Snowden where he has to sneak out the USB. That's based on what he
You've been to
described.
those type of places?
No, actually, one of my colleagues, he used to work for the DoD with the satellite, and yeah, not going to the bathroom by yourself was the criteria back then. Maybe different now, but all right. So the use we talked about how we can use SSL with HTTP, right? And then it was replaced by TLS. And then for the port that is used with, you can also use port 22, which is SSH, for secure file transfer protocol. So you can do FTP or secure FTP, and secure FTP just piggyback on SSH. So you authenticate using SSH in order to transfer files. They have a bunch of file servers that are still available, right? People put up files and then, you know, and I'm not talking about file sharing like what you've seen previously, but you know, for companies or even resources. For email, we talked about SMTP, Simple Mail Transfer Protocol, IMAP, POP3, and MIME. Okay. So when you set up your smartphone and you authenticate to your Google account or your Outlook account, right? Outlook.com or even live.com. Some of you might still have that. I'm old school, so I have Yahoo account and I use that for like stuff that I sign up for so I can get discounts or something like that. But yeah, that's POP3, and your phone actually automate this process now. Back in the days, you have to put in the server information and all of that. Okay.
Oh, I saw that. But I wanted to ask also, what is this?
Yeah.
In one of the email apps, you have to put the specific
Any
phone number
question?
and everything. I was like, what is this? Don't you just put in your email?
Okay, so the protocol that you would use to remotely connect to a Windows system, like if I need to connect to another Windows 10 or Windows Server to fix their system or to communicate. So when you're using like TeamViewer and stuff like that, some of those piggyback on these protocol, right? It established that direct connection. So you would have the RDP is for Windows, Remote Desktop Protocol. And in Microsoft, you can use Remote Assistance, which is the application that somebody can request, right? And it uses RDP to connect one system to another.
All right. So let's say let's say Facebook. Let's say you log in Facebook, right? You're on your homepage.
Mhm.
Can you still copy and paste the URL and open up another window, copy and paste? Will it still open up? Or you still-
Depending on whether you have that system remember your credential or not.
Yeah, it'll open it up unless you have it to clear cookies.
Mhm. So if you store the cookie, you store the
So it knows
credential.
who you are. 'Cause it has
But
a cookie
if
store.
but if I copy the URL and I try to use it on another system, it will not work.
Yeah.
All right. Any questions regarding these protocols and so I encourage you to go through, read, right? And then make sure that you understand these because it's a lot of information we're giving you technically, right? So I mentioned 443 for HTTPS. Now, when you are logging on to your student account here, they use Microsoft Server. And when you authenticate, it uses Kerberos. Okay, Kerberos is going to be repeated throughout all your security books. This is a protocol that Windows use for authentication. So when you authenticate, it gives you a key, and that key issues a ticket with the timestamp, and it uses port 88. Okay, this is one of the better protocol that will be more secure for authentication on Windows. Before wasn't so good, right? But they later on implemented this, and it's pretty strong. So, and then when you authenticate like to your RCCD account, right? It uses LDAP to identify who you are. Because remember we talked about access management last week, right? Your username and your password that comes from your LDAP service, your lightweight directory access control, and the server role is called Active Directory. It stores all your user account, your system information. It could be just a system, doesn't have to be a user account. And it uses the TCP port 636. It does have the TLS, incorporation to encrypt the data. And then it also, on the user side, the LDAP side, it uses also 389. And then we talked about remote desktop with RDP. This can be used for virtual private network. So now, depending on the type of virtual private network that we're using, so there are different types that we can set up. OpenSSH is known as the suite for SSH. This is often used everywhere for a lot of the Linux platform. It allows you to be able to connect to certain systems securely. Okay. And you simply use SSH command. And then one of the things that we have to know also is your simple network time protocol. This allows you to sync time with the network. This is important for us because there are certain things that we need to synchronize. Database is one of them. If your synchronization time is off, right, you cannot load your batch file. So whenever that you withdraw money from ATM or process a transaction, you know how it says pending on your account, right? If you guys have a bank account, that is. Not everyone does. Anyway, at the end of the day, right, the bank updates that they process a batch job where it's synced with your account, which is on a database. Okay. So they don't, activate that transaction right away. And it also gives the user time to kind of dispute and change that and so on, right? But most bank stuff is batch based.
Banks are like valid. But they're all-
Okay,
banks are like valid.
let's talk about DHCP. So your IP address is temporary. It can be leased as an assigned IP for a period of time. It depends on how they set it up. Normally, we would lease it for, let's say, 30 days or 60 days or 90 days, so that way it can be reused. Okay, so if that system is shut off for a long time, I can take that IP and give it to another system. So we can dynamically use the IP that way. Now, I had a typo here. Sorry, it was late when I probably put it together. So DHCP gives you an IP address subnet mask default gateway. You saw IP config earlier. That came from a server that served that system with the IP address, and that system got it, right? So when I boot the computer, it goes through that process in the network. It's gonna contact the server, say, hey, I need an IP. And then the server, the DHCP is gonna say, oh, here's an available IP. Do you want it? Right? So it's also a four-way, and then the system is gonna say, yeah, I like that. And then the DHCP server will say, okay, you can have it. So your router at home does that. It has that checkbox enabled, so it gives out the IP address to the rest of your system. That's why your router is 192.168.0.1. The rest, right, because it's in the same subnet or using the same subnet mask, the rest is 192.168.0.x.11.12.7 and so on. Okay. So when you do snooping, this is not a bad thing. This is a way that we would prevent unauthorized DHCP server. Remember what I said? When your port is open, somebody can walk by and plug things in and turn things on. And when you have a rogue DHCP, you know what happens? It gives out fake IP and it can wipe out your network. Okay. So long ago, I taught for a private school, and we have a rack, right? And my student, they set up DHCP server. And I always tell them, take the cable and then plug it so we loop back. We don't send out IP addresses to the rest of the network. And once in a while, you're gonna get one that forgets, right? So one of the group, they forgot to do that. So we broadcast IP addresses to everybody. So it wiped out the whole school. Yeah, because when you start giving out fake IP address that doesn't work in that network, that's what happens. So when you have a rogue DHCP, you can take out the whole network that way, because the system is always going to look for IP address, right? Okay. Funny story. Looking back. But I heard the administrator running down the hallway, and he was like, which class is giving out fake IP addresses? And I was like, uh-oh, that's not good. So I started pinging that, sure enough, right? Well, I told him, I said that my student forgot, right? I apologize. And then everybody reboots and everything's okay again, right? That's all it takes. I used to be an administrator, so I know. All right, so 15. So for snooping, we can prevent, it is a preventative measure. It's a way to prevent unauthorized DHCP servers, okay? You can also configure L2 switch. So when you see a layer 2 switch, so a switch can be different level. A switch can also have router capability if it's layer 3 and up. Okay. They all look the same. Right? Okay. So a physical port is a physical connection like this. Okay. So when we say disable a port on the switch, we literally mean that you configure the switch to turn off that port so it doesn't receive any electrical signal. Why is that? Someone can walk by, take a cable and plug it in and be part of your network. And if they're running DHCP, it broadcasts to everybody, right? Now, this is an older switch, and this is a layer 2 switch, okay? Some switches have router capability, which can route into the network and out of the network, okay? A lot of the companies use layer 4 switch, which has voice over IP capability. Okay? So, how do you know? You look at the model. Cisco have great documentation on what is what, right? Now compare that to a router. I mount this router backwards because if you look at the front of it, just lights, right? The router is really designed to connect in and out, and that's it. So you usually just have a couple of ports. Most new router will have fiber optic line. So this has some Ethernet, right? So on the router, you will only see a few connections because it's designed to connect to a switch and the switch connect to other systems. So if I have a switch like this, and if I have a bunch of computers like this, there's 48 computers in this room for you guys, right? Then I need at least 48 ports to physically connect with the cable, right? So then I will connect this switch to the router and the router to my ISP, just like home, okay? So there will be a drop line that's gonna come in. Now, sometimes they would have an uplink switch and all the baby switch, all the other, the next level switch is gonna connect to it. And it will be on a big rack like that in the back. It used to be on there and I took it out, but, so now on some of the switches are smaller. This is a 16 port, okay? So when you plug in the cable, it's gonna turn on the light and it's blinking just like how you've seen on your home router. Now, when you disable a certain port, right, even if they plug in the cable, it doesn't work, okay? And this is a patch panel. We use a patch panel to connect to other things, right? And the wire would be Ethernet or the raw wire. Okay. So the difference between IP version 4 address and the IP version 6 address, the IP version 4 is 32-bit, okay? And it would look something like this, right? 10.10.0.1, okay? Where the version 6, it would look something like this. F48 : and then it could be like 09:34, etc., like that. So the version 6 is what most companies use because we had the public IP, we ran out of version 4 in 2011, 10 years ago, 11 years ago. Okay. Now there are companies that still have them because they got a bunch of them, like Microsoft is one. So tech company, they would acquire a bunch of them. And IANA is the company that authorized those along with the DNS for public. Okay. So your internet service provider, they have a group of IP that they use for public. Okay. And we're transitioning to version 6 because we ran out of 4. So as we have more bits, your combinations in the numbers is higher. 2 to the 128 power compared to 2 to the 32. So if I take a calculator and I say 2 raise it to the power of 32, right? I would have this many IP addresses total. But why is it 2 to the power? Because it's binary ultimately, right? But if I take 2 and raise it to the power of 128, I would have tremendously more, right, in IP addresses. And eventually we will run out of those too, of course, right? And then we'll come up with a different number system for that. Yep. Oh, it's something else. Version 8, version 20. All right. DNS. So whenever you visit a website, google.com, nbc.edu, you're actually using a DNS with the web server. The web server, its job is to give you web content, the website, the web pages, the things that you can interact with on that website. The DNS is actually the URL, right? The .com, the .edu. So those are the domains. So the job of the domain name system is it's going to take that URL or the fully qualified domain name and convert it to the server IP address. Because ultimately everything is a computer system in the back. So when you type in a website address, right? Nobody is going to walk around and remember 142.110.whatever, right? So eventually what will happen is we have to make sure that it's associated that domain name to an IP. Okay, that's what the DNS does. Okay. And so can someone poison your DNS? Sure. Okay, so the DNS keep records of address and domain. That's record A. The quadruple A is for the IP version 6, right? And then also the reverse lookup. I can look up an IP address to a domain name, right? But someone can change that record, and they can route your traffic instead of going to google.com, they can make it go somewhere else. Okay? And that will be for different reasons, right? They can impersonate you. You know, they would route you and lure you to type in, you know, your information and fish things out. There are a lot of different reasons to really use this, right? So in order to prevent DNS poisoning, okay, we will implement what's called DNSSEC. And that stands for Domain Name System Security Extension. This is on, I'm sure it's going to be on your Security Plus, okay? This is just going to allow you to validate the response. So anytime that we do validation, it elevates the security. It doesn't remove it 100%, right? So it allows the system to digitally sign for it. And when system is digitally signed, it will be uniquely validating for the IAM that system. So it gives you data integrity ultimately. This is a simple option that now administrator can check that option on the configuration. It's really easy. Okay. But understanding how it works and why you're using it is important. Okay. Okay, I have about 15 minutes left or so. Okay. So you can also look up the DNS information a couple of ways. In Windows command line or command prompt, right? You can do IP config all. It's going to give you the DNS and the DHCP information. So compared to last time, I have more, right? I have the DHCP server address, the DNS, and here they have these, right? And they are virtual machines. I have scanned them before. So most company runs them as for VMs or cloud VMs because it saves money. Okay, so those are your DNS. And you can also do DNS lookup. Okay, and when you type in NS lookup, it simply just give you this. Now you can't always look up, right? See how it says unknown, because if they wanted to block that, they can, but I do see an IP for my when I do the NS lookup. Okay. Next. Okay, so that gives you a little bit. So it tells you open command prompt, type in NS lookup, press enter. What is the output? Answer that for me. Okay, for 19. So open up your command prompt by searching for CMD. Where do I search? The Windows search bar right here. I can type in CMD and open up your command prompt. Then you're going to type in NS lookup and then press enter. What do you see? And if you're using Apple system at home, that's different, right? This is the command that's used for Windows. So Linux, slightly different than Windows sometimes, for most part, actually. And then Apple is different than, close to Linux, but different than Windows. All right. So another thing that we want to talk about is your quality of service. So QoS really means that we would implement technology to make sure that we have control of a certain traffic type. So important things like phone calls, right? So let's say that you have a lot of use on your network, okay? I'm sure you guys understand bandwidth, as some of you might game at home. And like when let's say if I have 3 systems at home that's gaming at the same time, that's gonna flow my bandwidth a little bit, right? Or when we're streaming a lot, okay? So you have to consider what is important in your business, and you would use devices to make sure that that type of traffic gets priority, okay? So what do I mean? When people make phone call, right? You don't want them to ask the questions and that question doesn't go through until 5 seconds later. That phone call is just gonna be delayed. You ever talk and if you have like poor network, it's just really slow and you can't hear them and everything is choppy. So that's really frustrating, especially when you're doing sales or customer service on the phone, right? So what we would do is we would offset that. We would load balance. We would distribute our traffic so that way the phone calls would be handled as priority in our call center. Okay, but that's different in a manufacturing environment. Who cares if it's a little delay on the phone call? But things like design and stuff like that that needs to be sent and received, or transaction needs to be processed, is more important. So you will focus on the priority of your traffic, and you would use appliances and configurations and to be able to manage it. Sometimes you give it more, sometimes you give it less, right? So you have to regularly control that. And that's what QoS really means. And some appliances have that functionality, right? You just enable that option and then tell it what you want. Question? No? Okay. So the protocols that you often see, and this is also related to Cisco devices, you have the spanning tree protocol, and that later on they implemented what's called the rapid spanning tree. So in the switch, if you don't utilize this protocol, there's a slight chance that you might have flooding or a loopback. So when a switch have a loopback, it doesn't send, or when it does a broadcast storm, it just sends to everywhere, right, continuously. Then you're gonna have a problem. Then you're gonna have network issues. Okay, can somebody do that to your network? Sure. Okay, so it's really to prevent that. We need to make sure that we utilize these protocol, and the appliances will have. If your appliance have that feature, you would then need to configure. Okay. All right. So in the notes, it talks about different type of firewall. And in this industry, you need to know that. Okay. There are, you have to, because you have to distinguish the difference. Okay, so I talk about spanning tree, that's on page. This is a longer set of notes compared to last week. So 8, right, routers. So when you do a bridge, that means you connect 2 systems of the same, right? So I can bridge 2 switch together before I connect it to a router. I can bridge a computer to a computer. Now, when you're connecting the same device, if you're using Ethernet cable, they have to be crossover cable, okay? Not the regular Ethernet cable. Those are straight through.
Master, forgive me for asking this question. Sorry. What's the difference from internet, Ethernet, and intranet?
Intranet is like a subnetwork that would be used for the company to be able to share resources. It's not the internet. It's really part of that internal network, but it allows their employees to be able to access it from the outside, right? It's going to be more limited. Internet is when you leave the router and you enter the public network. You know what the internet is. And an Ethernet is a standard that we would use, 802.3. This is an IEEE 802.3 to be able to send signal via devices like your Ethernet cable, your Ethernet adapter, and so on. And your wireless is a different standard. It's 802.11. compared to an Ethernet. So it's different class in that standard.
Thank you.
There's also Arpanet, which is
Yes, there's so many different types, right? All right, host-based firewall. That's a software application for the firewall. So when you download and install your anti-malware, likely that it is a host-based firewall. Your Windows firewall is a host-based firewall. Application-based firewall, also a software. Now this can all, so the host-based, all that means is that it belongs to that system. So Windows firewall, application-based, you can use your anti-malware, right? Network-based firewall. This could be the actual appliance. Okay, it just overlooked the outgoing and the so firewall is a traffic cop, right? It inspects everything that comes in and it inspects everything that leaves. Okay, so you have to permit or so I normally set up the ACLs to allow certain things and everything else denied, right? That's easier than denying specific things. So when you set up parental control, when you're blocking like certain website, you're actually setting rules on your router, right? So your router acts as a filtering system, almost like a firewall completely, but not quite. So when you do that, you're setting up access control to certain things. You're blocking certain websites. So you rather allow them blocked. You will only allow a certain number and block everything else. Okay. So deny all here, enforce implicit strategy. A stateful firewall makes a decision that's based on the network traffic. So the state of the traffic. Okay. So stateful is useful, especially when you're aiming to really track or inspect traffic. Okay. And can you have different types? Sure, it should be that way. We should always layer things with different things because if you have a single point failure, that's a problem. If you have the same devices across, they found out how to attack one, they can attack all, right? So we have to design a solution where it is versatile, but it's also efficient. And so web-based firewall, it talks about that here. This is new in the Security Plus, right? The next generation firewall, you're gonna hear a lot of that in the industry. So that will be the advanced firewall that's after the first and the second generation. So the first generation means that it's inspecting the rules to block and allow traffic. The second generation means that it looks at the session rate. So it is a little higher in the level. And then after that, it will be your next generation, but you can also use it for deep packet sweeping or inspection. Okay. And a lot of these are intuitive. So coming back to the answer, right? We are using stateful firewall if we need to allow and deny and block. So when you use your router at home as that feature firewall that you have, right? Or your Windows firewall, you're using its stateful firewall to block or deny. Okay. And your next generation firewall, all that is it's performing deep packet inspection by adding application level inspection at the core feature. This up as some of you are still typing. So some might know DMZ, what it means. The military uses this a lot, right? So the militarized zone in the network, it is just an area in the network where it's between the internet and your network, okay? This is where your web server normally lives and some database, okay? It is really where all your devices that are facing the internet is allowing connection. So why is my web server gonna be there? Well, you gotta allow people to connect to it, okay? Now you would put it in some firewall there. Sometimes you would use an application firewall. Sometimes you would use host-based, depending on the need. A lot of companies use application-based firewall there. But you also put it before your regular firewall. So when I enter your network, I'm coming in from the internet. You have to visualize it physically. There should be a firewall to block things, right? Threats and things like that. And then if they bypass that, you should have something internally to detect and prevent. So you will do an IPS on the inside as well. So the DMZ is really the area where internet traffic can get to, right? But it should also be shield and filter, I should say shield, filter from your internal network. Design is the biggest thing for security. Every network has a flaw, and so you just have to fix that, right? Sometimes, most of our cases, people already design the network and connect it. You have to come in and find solutions to help it. All right. Few minutes left, and we can do the rest. Are we okay with this? Okay. And if we don't finish, we can finish next time. Your static net, bye, is a one-on-one map of your private to your public IP. Remember I said you have one public IP. So if I'm using my public IP, like my phone, my smartphone, that will be a one-to-one. The dynamic net at home, you have one public IP for your router and all your devices use that. So multiple public IP to one device. So if they're using multiple public IP for that one router, right, then it's one to many. And a proxy works as a middleman. Sometimes it can be a traffic cop, so you can filter it, or sometimes you can use it as a forwarder. So it can accept, forward, and modify your traffic based on filtering. You don't have to download Wireshark. You can actually open it up. By searching for it on your Windows search bar. And this is going to come up, right?
Professor, on the Unit 3 lecture and lab videos, the video for the lecture is not this lecture, right?
It is this lecture. I will post it. Oh yeah, the ones that on there is from the prior. It's from the older book. I'll take it down. I'll put this one up. I usually do that when I get home, so. Okay. So what you need is, we're just gonna have a few more minutes. So open up your Wireshark by searching for Wireshark. And then it will look like this. Okay. I'll put it up after I show you how to scan. So I'm gonna see a bunch of different adapters on here, right? So you are gonna be a little different than me because I'm on my laptop, okay? But you're gonna see one that has the graph like this. So you're gonna pick the local area connection that has the graph that's live, okay? Okay, one of the first ones. Since I'm on Wi-Fi, I have to pick this one, okay? And then once I select the adapter that I want, I click the shark fin. That's when you're gonna start your scan. So we're scanning everybody in the student network right now, right? So it's gonna be a lot. I only need you to do it for like a minute, okay? And then after that, you're gonna hit stop, okay? So we're gonna go now. Okay, you're gonna see this is everybody on the network. So you're using a sniffer or a protocol analyzer and you're listening in on all the traffic. Okay. And then we can pause, and if you wanted to, to really see stuff, you can open up browser and things like that. You can test this at home by downloading Wireshark. Wireshark's really fun. You can actually see, your roommates, what they're doing, what they're busy. You can look at things. Okay, we can pause it.
I think you can show for that.
No, this is not invasive, right? So you can just you scanning your network,
So
okay?
you can see which
But when
website-
you start doing something to their system, then that's a different story.
So
okay.
over here you can see the websites they're visiting and all that.
Yes. So there's invasive and non-invasive scanners, right? This is one of the non-invasive one where it just looks at what's happening. So you're gonna see a lot of different things. I just want you to, so it tells you to, once you stopped it, click the red button, then I want you to click the source tab. Okay. What you're doing is you're organizing, you're sorting by a certain destination. Okay. So I can quickly go from, you know, a certain IP to a certain IP, or categorize the same IP by clicking the source tab, where that's coming from. So if you're investigating like an attack, right? You scan it, and then a live attack, then you're gonna try to see the source. Where is that coming from? Okay. So here you can see some of these are, so this, okay. When you open up the packet to view, you double click it, and then it's gonna tell you the header information, and you can also click these to expand, okay, to find out more. So in the assignment, it just tells you, take the first packet after you click source, take a screenshot for me, so I know that you did it. Then you are going to look at the detail pane in the middle of the screen. And I want you to look at the destination address for that packet. And then what is the header link? Okay, so coming back here, this is my packet, right? Let me reselect that. Okay, so the first packet, you can see the destination address on there as well. So when you select that, when you open that up, right, you should be able to also see, let me see. So put the destination information and then the link, you can find that right there. You don't have to really expand on it, but you can look at the details here. It tells you like how long is that living for, 128 seconds. You know, so when we start evaluating the more details, then we can go a little deeper by expanding this. But you can put down the destination, which is that IP, and then your length is this. That's in bytes. Okay. And then also sometimes it tells you what device that is. This is a Cisco device right here. So based on the OS. So type out the answer and then click on the internet protocol and the transmission control protocol. So what do I mean by that? Click this right here. Okay. It tells me it's version 4 IP. And then click the transmission control protocol. So to answer that question, right, what is the ACK? If you can't find ACK information, just put none, okay? Because sometimes it's not an acknowledgement, okay? So when I click this and if I don't see anything that's ACK, then no. But if you do a ping traffic, you will find ACK and send. Okay, and that's all. I just want to kind of introduce you to Wireshark. So save your work, submit it by Sunday. Okay, if you have a hard time, you can also send it in a little later. I won't penalize so much. And I am available for questions. So close, make sure we shut down the computer before we go. Have a good afternoon. And then I'm gonna stop recording so I can upload later. I'll stick around for a question for a few minutes.